session we are going to start with our new chapter, that is boiler. This is Faizan Kakti and I welcome you all to our lecture series of basic mechanical engineering. So let's begin. Now, the first question comes in our mind that what is boiler? So we would say that the function of boiler is to generate steam from water. But as we know that steam cannot be generated by itself. For generating steam, we need to supply heat energy to water, right? So how we can do that? So we would say we are going to feed coal, that is fuel, inside a boiler. Combustion of coal will take place. It will generate hot gases. That hot gases will transfer its heat energy to water, and water will gradually get converted into steam. So this is how steam will be generated inside a boiler. Steam generated can be of three types, that is, it could be a wet steam, dry steam or superheated steam. Now there is a regulation called Indian Boiler Regulation who passes various laws for the safety and operation of a boiler. So it has given a definition for a boiler, that is, according to IBR, boiler is defined as a closed pressure vessel in which steam is generated with a capacity exceeding 25 liters, gas pressure greater than or equal to 1 kg per centimeter square. So if we convert 1 kg per centimeter square into bar, so it is equal to 0.98 bar. 0.98 bar. Okay. And water is heated at 100 degrees Celsius or above. So if these three conditions, that is capacity of steam exceeding 25 liters, gas pressure greater than 0.98 bar and water is heated above 100 degrees Celsius, then we can say the closed pressure vessel is called a boiler according to IBR. Okay. Now next we need to see classification of a boiler. So first classification is based on geometric orientation, that is how boiler is placed on the ground surface. Okay. So if the axis of boiler is horizontal, then we would say the boiler is called a horizontal boiler. If its axis is vertical, then boiler is called vertical boiler. And if the axis of boiler shell is inclined, then we would say it is an inclined boiler. Okay. Now examples are given. So locomotive boiler is a horizontal boiler, whereas Cochran boiler is a vertical boiler. We are going to see Cochran boiler, so you will get an idea. Okay. Next classification is based on according to working pressure. So according to that, three categories are there. First, low pressure boiler, second, medium pressure, and third, high pressure. In a low pressure boiler, pressure varies from 3 to 10 bar. Okay. So under this category, the boilers are Cochran boiler and Cornish boiler. In medium pressure boiler, pressure ranges from 10 bar to 25 bar. So under this category, boilers are Lancashire boiler and locomotive boiler. And third, high pressure boiler. So in this type of boiler, pressure of a steam generated will be above 25 bar. So example is Babcock and Wilcox boiler. Okay. Next classification is based on according to location of a furnace. That is where a combustion chamber is placed, whether inside the boiler shell or outside the boiler shell. So based on that, it is classified as first, externally fired boiler, and second, internally fired boiler. Externally fired boiler means the combustion chamber is placed outside the boiler shell, whereas in internally fired boiler, combustion chamber is inside the boiler shell. Now example of externally fired are Babcock and Wilcox boiler, whereas in case of internally fired boiler, example are Cochran boiler and Lancashire boiler. Okay, next classification is based on according to relative position of water and hot gases. So according to that, first type is a fire tube boiler. Now what is fire tube boiler? So inside a boiler shell, there are number of tubes passing. Okay, if from within that tube hot gases are flowing and surrounding that tube there is water, then such tube is called a fire tube boiler. Okay. Then such boiler is called a fire tube boiler. Why? Because hot gases are flowing through the tube. Okay. Whereas second type is a water tube boiler. So in water tube boiler, water will flow through the tubes and hot gases will be surrounding the tube. Then such boiler is called a water tube boiler. Now example of fire tube boiler are Cochran boiler and Lancashire boiler. Whereas in case of water tube boiler, the examples are Babcock and Wilcox boiler. So you have to remember this category, all the characteristics, you have to mention these characteristics while explaining all the types of boiler. Okay. Now next type of characteristic, that is classification. So we would say according to number of tubes in a boiler shell. So based on that, first type is called a single tube boiler and second type is called a multi-tube boiler. Now what is single tube boiler? So we can easily predict that if there is only one tube present inside a boiler shell, then such boiler is called a single tube boiler. Okay, whereas in multi-tube boiler, the number of tubes will be more than one inside a boiler shell. Okay, so what is the main difference? So we can say that higher is the number of tubes present in a boiler shell, which means higher will be the heat transfer area. Okay, or we would say more exposure of area is given to water as well as to hot gases, so that heat transfer can take place from a hot gases to water in order to generate steam. Okay, so this is a benefit that steam generation rate can be increased if more number of tubes are provided inside a boiler shell. So the examples for a single tube boiler is first in that case Cornish boiler, whereas in case of a multi-tube boiler, that is example is Cochran boiler and Lancashire boiler. Next point, that is 6, according to method of water circulation. So based on this type, we would say there are two main categories. First, natural circulation of water, and second boiler is a forced circulation, in which forced circulation of water takes place. So in natural circulation, we can say if flow of water takes place naturally due to density difference because of convection, that is natural convection of heat, then such boiler are referred to as a natural circulation boiler, in which water circulation takes place naturally due to density difference. This is the most important term. Whereas in case of a forced circulation boiler, the flow of water inside a boiler shell takes place by means of a high pressurized pump. Okay, that is, pump is going to exert a pressure on water to circulate the water to increase the steam generation rate. So forced circulation is used, remember, when steam generation rate required is much higher. Okay, so that heat transfer rate can be increased by means of a pump, that is by increasing a pressure of a water. Whereas in case of a natural circulation, water is naturally going to circulate because of density difference. Now example of a natural circulation boiler is Cochran boiler, whereas in case of a forced circulation, the boilers are Benson boiler and Lamount boiler. Okay, now let us see the next topic, that is the difference between a fire tube boiler and a water tube boiler. So first point is based on a position of hot gases and water. So in case of fire tube boiler, we can say hot gases are inside the tubes and water is outside the tube in a boiler shell. Whereas in case of water tube, we can say water is inside the tube and hot gas is outside the tube in a boiler shell. Now second point is based on operating pressure. So we can say that in a fire tube boiler, operating pressure is limited up to 25 bar, whereas in case of a water tube boiler, operating pressure is as high as 125 bar, which means we can obtain high pressure of a steam in case of a water tube boiler. Third is based on a steam generation. So we can say that fire tube boiler has a lower steam generation rate, whereas in case of a water tube boiler, higher is a steam generation rate. Okay. Fourth is not suitable for large power plant. So fire tube is not suitable for a large power plant, whereas water tube boiler is suitable for a larger power plant, that is electricity generation plant. We can use this type of a boiler for external combustion engine. Okay. Fifth, more floor space is required in case of fire tube boiler, whereas in case of water tube boiler, less floor space is required. So this you will get an idea when you will study Cochran boiler and Babcock and Wilcox boiler. Okay. Next point is based on cost. So we can say that fire tube boiler is less costlier compared to water tube, whereas water tube is more costlier. So the reason is very simple, that in fire tube boiler steam generation is lesser, which means the cost will also be less, whereas in case of a water tube boiler steam generation rate is much higher, as well as high pressure can be achieved in this type of a boiler, so initial investment will be much higher in case of water tube boiler. Next point is based on a application. So we can say that fire tube is used for producing process steam, whereas the water tube boiler are used for producing steam for power generation, that is for electricity generation. Okay, now let us see our next topic. So next we need to see basic parts of a boiler. In that, first part is called cylindrical shell. Okay, so it is a shell in which different parts of a boiler are enclosed and on which different mountings are fitted. Okay, second is grate. Now what is grate? So we would say grate is a platform in a furnace on which coal will be placed and combustion of coal will take place. Okay, next is furnace, that is firebox. So we would say it is a place at which the combustion of fuel takes place, and it is also called as a firepot. The chamber contains hot gases produced by combustion of fuel, that is combustion of coal. Okay, next basic part is ash pit. Now ash pit will be provided below the furnace. The purpose of ash pit is to collect the burned carbon, that is after combustion of coal we know ashes are generated. So there will be two types of ashes. First is called a fly ash, second is called a heavy ash. So heavy ash always remains on a combustion chamber, or we would say on a grate, whereas fly ash will fly along with hot gases. So whatever ashes which are present will be collected in a pit, that is called a ash pit. Okay, next part is called a smoke chamber, or even it's called a smoke box. So the waste gases are collected here and then released to the chimney and then finally to the atmosphere. Okay, next is main hole. So as the name itself suggests, that main hole, which means there will be some hole provided on a boiler shell through which a worker or an operator can enter into a boiler shell in order to inspect the internal parts of a boiler. Okay, that is, he would see whether some parts are worn out or not, and if it is worn out, then he will perform the maintenance of that parts. Okay, even for a cleaning purpose, worker can enter into a boiler shell. So for that, main hole is provided. Now let us see the next part, that is hand holes. Now it is a hole provided on the shell to give easy access for the purpose of cleaning the tubes, specifically water tubes of a boiler or some other internal parts of a boiler. They are fitted with the covers. Okay, so if a worker doesn't want to enter directly through the main hole, so he can also make use of a hand hole, which is giving a direct access to the water tubes. It is required to clean the water tubes periodically. Why? Because whenever water is heated, so we know salt is present in a water, so scale deposition can take place on an internal surface of the tube. If that is not removed, then we can say heat transfer rate can be reduced and even explosion of a tube can take place. So for that, cleaning of these tubes are very much necessary, and for that hand hole is provided. Next is mud box. It collects all the impurities present in a water. So as the name itself suggests, that is, mud box is going to collect sediments, salts, or we can say that heavy impurities which are present in water will be easily collected in this mud box. So mud box is provided at the bottom of a shell. Okay, these impurities are removed time to time by means of a coke, that is called a blow of coke. Okay, we will see how it's going to operate. Okay, next part, that is steam collecting pipe. It is even called as an anti-priming pipe. So the steam leaving the boiler, it contains certain amount of water. Anti-priming pipe is used to separate water particles from the steam and collect dry steam from a boiler. So steam usually generated inside a boiler will always be a wet steam. The reason is that that steam will always remain in contact with the water level. Okay, so moisture content will always be present in that steam. So for removing water molecules from that wet steam, it is required to pass that steam through this pipe, that is called an anti-priming pipe, which will remove all the water molecules from the steam and will convert that steam into a dry steam. Okay guys, so in today's session we are keeping up till here. In our next session we will see different types of boiler. So till then, stay tuned and thank you all.